Hi, everyone. I think we can start now. Thank you for coming to the session. My name is Alina. I work at JetBrains, and I work in a team which is doing both development and infrastructure. And my today's talk, how to collect application metrics if it needs to be done yesterday, I will try to cover it from the various sides, both from development, operation, also a bit of the user experience, and overall impression of the big picture. So to start with, I would like to set the goals of this talk in general. And first of all, I want to share some experiences that I've seen in the recent years, and also I really hope that you will find something beneficial for you as well. I'm gonna try to show it all on the examples to just not wave hands here. And to start with, what we want to achieve in general with our software. We want to make customers happy. That's a major goal, and I like to think about everything from this perspective. So even if we are talking about the system metrics, yes, basically we are observing the system overall health, performance, how stable it is. But what we actually want to do is to empathize with what the user sees, how they perceive our system, and what the experience is. The second point is that we want to reduce the load of the team, because generally speaking, all the development teams and DevOps teams are highly overloaded, and at least what I see is that we always face a challenge of people resources, so to say, because it's always a time pressure, a lot of tasks, and it's really hard to keep it up with everything. And the last but not the least, like since we're talking about software, if we're talking about companies, we're talking about business, so obviously enough, we want to save money and not to spend a whole fortune on just the monitoring of our software. And here's a brief structure of what we're gonna cover today. So we start with spotting the problems, how we can detect them. Then we move towards the topic of the perceived performance, considering both from the client and server. Here, as a basis, I take a very basic client-server application to set the example. And then we perceive with factors that influence our performance indirectly. Then move on to the alerting and wrap up with the best practices. Also, I want to mention that I won't cover the logging here and also performance testing, because time is limited and I prefer not to shift the focus too much. So, first of all, if we start with the monitoring, first of all, it's was mentioning how we can monitor everything. And here's just some examples of the software which you could use for the monitoring and metric collections. Probably you already know a lot of those tools. And here the trade-off that we always face is that we have two choices. Either we go with, let's say, open source solution, or we invent something ourselves, but then it's going to be increased costs on the team because it requires a lot of maintenance, a lot of development, you need more people to this, but you save money. On the other hand, you can just connect a third-party monitoring solution, and basically that's it. End of the talk, thank you for attention, we get all the metrics collected. But most likely, you spend a lot of money on this if you just do it blindly and connect it as a black box solution. So here's just the overview. Please do your own research to find out which tool is the best suitable for your need. And now we will proceed with how we can use both open source or third party, doesn't matter, for more reasonable metrics collection. So let's start with a thing of how to spot that you have problems. And the most obvious thing how you spot them is when your customer support is overloaded with the user complaining, nothing is working or everything is so slow, do something. Probably at this point it's already too late and you already missed your chance to actually optimize the software with metric collection and monitoring. But still, it's a very good and precise indicator that something is going wrong. But how we can spot the problems before we actually reach this phase of a lot of users complaining to the support. Of course, with metrics monitoring, and the three basic metrics that we usually monitor are utilization, saturation, and errors, and we can monitor them applicably to the hardware resources, such as CPU cycles or disk and network input-output, or software resources. For example, we can define the utilization of the thread pool as a number of threads currently executing the tasks, or saturation of the lock, judging by the number of threads waiting for this lock to get free. But of course, if we just use the phrases like everything is slow or we need to speed things up, it doesn't give much sense because we lack here some concrete details. And to quantify performance, we usually use terms such as latency, elapsed time, and throughput. And you can see a couple of examples on the slide. And basically, here are our bases to set if we want to monitor the basic state of the system without perceived performance for now. So here's an example of the cloud software with which is located on the host machine. We have two GVMs here, and the metrics are monitored per GVM. Here's another example of how this could look. So we monitor all the basic hardware metrics here, and with this graph, we basically receive the overview of the state of our system. Okay, now we see how much memory is consumed, we see how many disk is utilized, also some metrics related to the GVM state. And the next question is, what now? Okay, you covered it with the basic metrics, you have the overall picture. What are you going to do with this? And here it comes with, in my opinion, the most important part of the whole thing with the metrics, perceived performance. Since we want to emphasize with what user sees, it's crucial to understand how our system looks from outside, not from inside. Because you can cover yourself as metrics as long as you want, but if you're unable to draw a certain part of your system, it means nothing. So I want to talk about perceived performance in terms of this example. So here we have a long-standing, large production application. And actually, that was a major inspiration for this talk, because I observed several cases like this, when you already have a massive application which already has a lot of customers, and at a certain point, you experience performance degradation. And of course, you wonder why. But if you don't have an extensive coverage with metrics at this point, it's quite hard to start. You already have a lot of code. You already have a lot of subsystems. It's indeed huge. And to cover it extensively with metrics, you might spend probably half a year and an effort of 2-3 people from the development and ops team. So how we can do it a bit faster? Let's consider this example. We have a GVM application, a server one. We have a front end connecting to our server. We also have a mobile app, and it also allows third-party apps to connect using the API. So basically here you can see all the major characteristics of this example app. So it contains a lot of multiple subsystems, connections from both UI and API, wide permission scheme, which is usually the case. You have admins, guests, different users, etc. And just as an example, the embedded database. So how we define metrics for this example? And here we talk about dimensionality and what properties our metric should have in this particular scenario. So first of all, consider the first factor, multiple subsystems. Logically enough, the first hypothesis that we have is that different subsystems experience different load, and it won't be wise to compare, let's say, heavy input-output operations with heavily computing operations. So we define a metrics bucket per subsystem. So for this scenario, let's say it's tasks. So you have a certain task tracking system, and this subsystem is responsible for the list of tasks. So you define a bucket for it. Then we turn to the next property. And for this, we have the following hypothesis. So we know, we wrote our application, and we know that requests made by users are most likely heavier than API, as the query is longer. We know the front-end query, and it's indeed huge because we need to request a lot of properties. And most likely, the users that are using API will request only the properties that they need. So we split it into two buckets, not to mix. And in this particular example, we want to focus on the left bucket since we want to see the perceived performance of the user in the browser. Next, we have the wide permission scheme. What to do with this? So here, the hypothesis would be that the requests made by a certain team, let's say admins, they're heavier than the ones that are made by guests, and they have more permissions, and therefore they can see more data, and it takes longer to execute the very same query. Therefore, we include also the division by request type, obvious, and inside of this, we include different groups for the different user types. This way, we are not mixing guest queries with admin queries, and it gives us a bit clearer picture. And the last point is the embedded database. So generally, if you have not embedded database, you have also connection to database. But here, you somehow get down through the application code into the DB code consequently. And therefore, we don't need to measure any metrics for the connection, and we can focus on the database performance separately. It will require some additional benchmarking, but the major case here is that we don't need this connection metric. So here's an example how you can do this via code. Here I'm just using New Relic, and as you can see, we record metric with dimensions that we just discussed. And on this example, it's just personal preference, but I prefer, rather than just annotating it and sending all the request data, I prefer to send metrics manually, because this way the data ingest is way lower, and at the same time you have more control because you do everything by hand. It's also a little bit more time consuming, but you have more control of the situation and less data ingest. So that's how the dashboard would look like if we build it for multiple subsystems. And if we want to query the specific result, it would look like this. So I want to see a certain metric, in our case it's RPS, for articles subsystem, for the GET request type, for mobile app query or front-end app query by user type. And you basically can see this. So that was the backend part. That was a server metric and request per second. Of course, there should be multiple metrics, such as response type and etc. But what about the front-end monitoring? So the good starting point for the monitoring of the front end would be the Web Vitals, which were introduced by Google, and it's considered now a solid foundation for the front end monitoring. It includes the core vitals and some additional metrics, and they should be measured depending on the device and network, and they also have an impact on how your application, how your web service is indexed by the search engines. But here's the problem, because now more and more popularity is gained by the single-page app. I'm pretty sure everyone heard about it, and the most common traps that I've seen so far is that people are trying to implement the front-end metrics, not taking into account the differences between the multi-page and single-page app, and therefore they receive incorrect results of the observability, and they improve the wrong points and the wrong parts. So we won't dive in a very details into the differences, but I want to highlight the key differences between those two apps to understand better how they have the direct impact on the metrics. So first of all, what is a single-page app? Single-page app is used to not reload the page on every user action. So with the help of the virtual pages, it allows to dynamically update the content without the refreshing the full page. And with this, it provides a better user experience due to those dynamic UI updates. But at the same time, you pay for this with a longer initial page load time, which directly impact the Web Vitals that I mentioned earlier. The next step would be that it provides improved performance due to caching and lazy load, but for this, you actually pay with problems with search engine crawling, because, again, those metrics, Web Vitals, they're not taken into account those dynamic updates. So they solely focus on the dynamic updates. So the dynamic updates, they are not taken into account those dynamic updates. So they solely focus on the 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 dynamic updates. So they solely focus of page refreshes, and in a single page app, that's only a part of the job to be done. The next point would be that it provides a reduced server load, but at the same time, it requires way more effort from both development and infrastructure teams. So the major problem here is that, as I mentioned before, the web vitals, they were initially created without SPA in mind, and they are not adapted for this. So if your application is single-page app, then what you can measure instead is the dynamic page updates separately, taking into account this. Also, the AJAX request data, also separate performance data and throughput for the page loads and route changes separately. Like page loads, it's like initial page load. Route change is this dynamic update. And also synchronous and asynchronous JavaScript activity. And now that's been several steps taken by Google to also adapt the Web Vitals to single-page apps, since it's gaining more and more popularity. It's not turned on by default at the moment, but you can enable and play it explicitly via the features flag. And here's an example how it would look like with a single-page app. Of course, the error rates, separate metrics for the initial page loads and route changes. OK, for the mobile, it's again, I'm mostly focused on Android, but with Apple, it's kind of like a similar concept. But today we're going to talk about Android mostly. Again, Google created a number of vitals, also similar to what we've seen for the front end. And the two major metrics that should be measured here are the user perceived crash rate and also the number of users experiencing the application not responding error. Another important part could be the time to initial display and the time to fully drawn. And the core goal of all these metrics is to measure how responsive your application is, how stable it is. Also, there are a number of metrics denoting the size of application, how fast it should be downloaded, and also how much space it's taken. Another important point is indirect performance, and namely in our case, the concurrent applications. It's hard to find an application which is not concurrent right now if you're talking about traditional applications, and especially if you're talking about Java applications. And today I want to talk about the thread pools a bit more in details. So thread pools are very widely used concept nowadays, and as far as I know, it's one of the most used concepts for multi-threading in Java. And let's consider the following example. So we have a long-standing production app, of course, it's concurrent. And we have a number of thread pools and the number of thread pools executor. So basically, in an executor, we have a queue of work to be done and also a pool of threads available to execute tasks. What we can configure for such case is the pool size and the number of pools. And there is like this book rule, how you can define the number of threads, though I'm a bit more adept of like try and error approach. So it might be a good start, but of course it's nowhere near the silver bullet. So I hugely encourage everyone to try and experiment with the pool sizes, depending on how well you know application. But it's a good starting point. So what we can do with this? Let's say we have an application which is sending tasks to the different thread pool executor queues. And we better split those tasks depending on the subsystems or like type of the load, because generally speaking, in a large application, we need more than one thread pool and more than one thread pool executor. So let's say we have multiple. We also have an additional thread pool, which can donate, let's say, threads to the general pools. And if we feel that a certain pool is utilized enough, then we can add to it. If it's utilized too much, then we can take threads away from this. So with this, we enable the auto-scaling for the thread pools. And for this particular scenario, what we can monitor is we can monitor the max thread pool size you can see this on the left side, and the current pool size. With those fluctuations, it's clearly seen where the threads were added or removed from the major pool. And with this, you can see the dynamic of how well the thread pools are utilized and where we need more threads, which parts of the system are experiencing higher load than usual. This is another example of what we can implement in the jobs monitoring. So, of course, the number of completed jobs, number of failed jobs per processor, processor max running time, and with this we can see clearly where the peaks of activity are. And generally speaking, at least what I've seen in my experience, those graphs were extremely helpful when we had bigger upgrades with the larger customers, because those graphs allowed to monitor how stable the upgrade process was. Because when something went wrong, we had like complete stop with the long-lasting threads, and due to those plots, it was easier to reflect on which parts of the system they were taken. Okay, so let's say we collected all the important metrics. We covered the system quite extensively. Now, what we're gonna do, of course, we're gonna use alerts. When a certain metric is reaching the threshold, there is an alert, which is usually coming to the on-call engineer. And I have a question to you, like, who's ever been on call? Did you like it? No? Can someone tell why? Okay. Okay, fair enough. Well, at least when I was on call, I can share like one of the struggles that I had, is that if there were like so many alerts, if there were like, I don't know, again, the upgrade process or something else, if the number of alerts is too high, then I start to perceive them as a noise. So usually speaking, we are humans, so our cognitive abilities to perceive the urgent situation is limited. And if we have too many urgent situations, and alerts are usually urgent, then we kind of stop reacting on them that fast, because when you receive alert, what should happen? You should like urgently pull yourself up and like run, fix something. But if you receive those alerts like 100 times a day, 1,000 times a day, then you just start perceiving it as normal, and it should be normal. So this is quite simple, but as far as I see, like all those things which are related to alerts should be simple. So that's how I would split the alerts if I was building a system. So if something happens in your system and it's urgent and it requires human intervention, only in this case it should be an alert. If it's not urgent, but with a human interaction, it should be a ticket. And if it doesn't require a human interaction, you're good with just an automations. So the major point of alerts is to make it so that on-call engineer should be able to react on this, but at the same time not overload him or her with like extensive alerts. And of course, like incidents happen. It's okay, like we all humans, incidents could happen, but what we want is no outages. So the major goal is to spot the problem and fix the problem before it reaches the customer, and you have this like overloaded customer support with like, nothing is working or everything is so slow. So incidents are crucial in the structure in a way, but how well we react and how fast we solve them, it's the most tricky and most important part. One of the examples that I personally find very useful when it comes to automations is the cloud balancing. So let's say you have multiple machines deployed in a cloud and you have multiple applications running. And if you need to move the application from one host to another, usually an engineer would go and pick the applicable host which is suitable for the move in terms of, I don't know, disk space or CPU. But you can easily replace this with automation, which can which can pick the next host just based on a certain set of rules. And this way, we lower down the load on the on-call engineers or general infrastructure engineers. So in my opinion, this is one of the really cool cases for the automations. And now let's move on to the good practices and how we can make the whole way of observability smoother. So first of all, it's postmortems. Well, again, as I mentioned, incidents are almost always unavoidable. Our goal is to not make it outages and not make it touch the clients. So if something, for any reason, happens, we need to thoughtfully evaluate it, find out what was missing, what metrics were missing, and find out which data could have been there to let us resolve this incident faster. The next point is most important in my opinion is knowledge sharing. If your team is certain that you developers and infrastructure guys are working together already, it's good, but add on-call engineers there, add support engineers there. Ensure as smooth communication as possible, especially with L1, L2 support, especially with the developers, and especially with the DevOps team. As long as knowledge sharing is easy and everyone knows how to do it in a less painful way, not diving into a lot of bureaucracy, that's the easiest key to reduce the number of the incidents happening. And here comes the next point, is that the process of new instrumentation and more important, more new practices should be simple. And if you find out that some data is missing, if you find out that some metrics could have been there to help you, it should be really easy to go and directly add it either in your source code or into your infrastructure. Next one is a dashboard. So I personally like the top-down approach when a certain dashboards display more or less a high-level picture of your software, and also it would be great to add some SLAs on it to also present to non-technical users in case they need it. Sorry, not users, but people you're working with. And slowly drill down to more and more precise metrics and services description, which are used by different teams. And basically I've already mentioned this. Mentioning some contextual information is really cool, especially if you want to talk to management or if you want to share it with some other teams with whom you are working. And generally speaking, I want to actually point out this last part about the team. From what I've seen, the team is the most important part. We can talk hours about how to do it well from the technical side, how to do it properly, extensively. But what is most important is the team, how well the team communicates, how well everyone knows what they should do in case of incidents, and in general, conflict or problem situations. So from what I see, if you have a good communication level in a team, then that's already half of the success. And even if you're missing something in terms of metrics or coverage or logs, it will be solved sooner or later if you have a good communication within the team. And to answer the question that this was stated in the very beginning, how to collect application metrics if it had to be done yesterday, the most honest answer would be there is no way. You can't do it in one day or so, but everything I mentioned before, it could give a very solid foundation for the further improvements, because observability is any other process. It's continuous process. You can't do this one for the future and never return to this again. So there is always something to be improved. There is always something to work on, but this foundation could give you a nice overview of what's happening in your system and what can be done in the first place. So if you talk about the prioritization here, with this, it's easier to prioritize what are the key problems you have and gradually start improving everything. Thank you for your attention. Please, if you have any questions, feel free to ask. Thank you.